Alright, so this is the last video for the stoichiometry unit, and we're going to talk about something called percent yield. So let's start out with a chemical reaction. We'll do something pretty simple. Let's try, let's say iron chloride is going to decompose to form iron and chlorine. Rewrite that. Okay, so if we balance that, okay, so I'm going to do the stoichiometry for you here. Let's say we do the calculation and we find that we should get 27.6 grams of iron produced by this reaction. Okay, so this is called the reaction yield. Yield just being the product. Now we got this number through stoichiometry, right? If we do this reaction, this is what we should get. Well, we call this value the theoretical yield. Okay? Theoretical yield is the expected product from a reaction. The expected product, I'm going to abbreviate here, from a chemical reaction. Alright? So, that's our theoretical yield. Now, anybody who's ever done a lab before knows that it never actually goes as you plan, at least not perfectly. There's always going to be various sources of error. So if we did this lab, chances are we are not going to get that number exactly. If we do the lab, we're probably going to get something along the lines of, 26.5, 24.3, something a little bit lower. We call this number the actual yield. Okay? The actual product obtained from a chemical reaction. Okay? So the theoretical yield is the expected amount of product. The actual yield is what you actually get. Now, obviously, if you're working as a chemist or working in some kind of business where you're invested in how much product you can make, you want to get as close to that theoretical number as you can because, money relies on it. So, basically, there is a measure called percent yield. Okay? Ideally, you want 100% yield. If we did this reaction and I was working in a factory or a plant or something, I would like to get 27.6 grams of iron. I'd like to get exactly that. That would be 100% yield. Chances are it's not going to happen though. So after I've actually done my reaction and got my product, there's a way to calculate percent yield, and it's pretty simple. You take your actual yield, you divide it by your theoretical yield, then you multiply that number by 100%. So that's all there is to it. So let's say here's our theoretical yield up here, 27.6 grams. Let's say I actually go do the lab one day, decompose iron chloride, form iron and chlorine, and I weigh my iron product. Okay? So our actual yield, let's say we get 26.4 grams of iron. Alright, so we can look at that number and say, yeah, that's kind of close, not very far off by a little bit more than a gram. So, how close are we as a percentage? Well, let's try the math. So what did I say, 26.4 grams? Okay, 26.4 grams of iron divided by 27.6 grams of iron. 100%. Okay, so let me punch that in a calculator. 26.4 divided by 27.6, and we get times 100, and we get 95.7%. So there's our percent yield for that particular reaction. Now, I think that's pretty good. Anything up there in the 90s, that's actually pretty good. It depends on the reaction. Some of them are more difficult to get a pure yield, but this, I would consider that pretty good. So I'm going to do one practice problem. I think this is a pretty simple concept. So let me set the problem up, and you can try it yourself. and then look at the solution. So let's say you have calcium carbonate decomposing to form calcium oxide and carbon dioxide. Okay? Let's say our reaction says that we should get 29.35 grams of calcium oxide. There's your theoretical yield. Okay? But we actually are able to produce 17.42 grams of calcium oxide. So I want you to calculate percent yields. So go ahead and pause it, try it, check back for the solution. Should be pretty simple. Alright, so all you got to do is divide 17.42 by 29.35, multiply that by 100% just to convert it to a percentage, and you get 59.35%. That's not so good. That's probably, well, not probably, that's lower than you wanted, especially if something's riding on this, if this is your career. In a high school lab, it's probably not terrible. That's what we got. So that's it for percent yield. Just keep that in mind, that in the real world, you're not going to get your theoretical yield. You want to be as close to it as you can by avoiding different types of error, but you're not going to be perfect. Alright, so that's it for the stoichiometry unit. If you had trouble with any of the things that we've gone over, just go find some more practice problems. You can always send me an email or come in before or after school. Alright, hope that was